work. All right, so here's a few news articles. This one, Caitlin just showed me, is great. So group policy is Microsoft's central management control, where they can do things like lock you out of the control panel and limit what you do with your machine and stuff. And if you're a pen tester or anybody that wants to like break the policy, it's annoying. And what these guys found is, I've heard of this years ago in some Microsoft certification class, there's a thing called ntuser.dat, which is where all your settings are set, but there's an alternate file called ntuser.man, which is a mandatory setting file. And if you change dat to man, it's now exempt from group policy, which is pretty awesome. So that's a simple hack to get around Microsoft group policy. And of course, all these security features are usually pretty easy to get around. All the pen testers know how to blast through most of these things. Anyway, this is another one. So Docker won't run if you have Razor Synapse Management Tool running. And this I thought was pretty fun. This reminds me of about 4 years ago, I could not run VMware and VirtualBox on my Mac at the same time because they both used certain local resources that were sort of like interrupts. And you had to run a special command line script to keep letting one program let go of them. They finally fixed that. But here's the point. They created global Mutex, which we talk about in the malware analysis class. They created global Mutex. And what they do is execute this command to make a Mutex named after the program. And this is wrong. This makes a Mutex that is named after the type of program it is. The get type is a mistake. So this creates a Mutex with a name called System Reflection Runtime Assembly. And therefore, any other program that uses this same flawed instruction will try to make an identical Mutex, and you can't have two Mutexes with the same name. So two programs that people commonly use are both trying to do the same wrong thing. And the answer is, of course, Stack Overflow. If you Google how to do this, Stack Overflow in 2009 has this as the example. And then in the comments, they say, no, that's wrong. But a lot of people don't read past the comments. Some of us here might have been guilty of this too. We're like rushing to get something done. We Google Stack Overflow, we find the first thing we see, we copy it, and if it works, we just keep going saying everything looks okay. And anyway, so apparently Docker did that, and somebody else did that too. So that's good, clean fun. Anyway, so this, I thought about this years ago. I just hit the press again. This guy wrote an automatic lawsuit app. And what it will do is he gives you a fake credit card number that you can use to talk to the people that call you and find out who they are, and then it will help you fill out the forms to sue them for like $3,000 for everyone that calls you. There have been many attempts to do this. One was called, I forget what it's called, about 10 years ago, there was one that would automatically, every time you got a spam, it would send junk back to the server that came from, so he had a giant DOS on all the servers, and so they threatened him with lawsuits, and then they modified it to just fill out the comment form of every company that advertised in spam, which would accomplish the same thing but be legal. And then a Russian spam crime gang hacked into the main server, stole the database, published some of it, and said, we're going to personally hunt down and hurt all the people that use this app. And the people who made the app took it down and said, forget the whole thing, because they were scared of the Russian mob. So that means it was very effective, because spam is big business, and it's the Russian organized crime doing it. So anyway, so there's this app. Some people are using a smartphone-based voting app. It's been used in several elections, but not a major thing like presidential elections. Small districts have used it for small purposes, and this is from Votes. And I saw this company about 2 years ago. Votes came out, they advertised their app was secure, and I gave them some trouble back then, and other people gave them trouble. And they said, what makes you think it's secure? And they just replied with like a Qualys SSL test of their HTTPS certificate. Say, there, we have a security certificate. That means we're secure. And everybody jumped all over it and said, you idiots. There's a lot more to it than that. And so now MIT did an analysis of it and published a paper saying they analyzed the app, and they found various flaws, which they also said that there was no source code and no documentation, and so they had to kind of guess what the server should be and make their own server. And anyway, this claim claims to be secure because it's using a blockchain, but these guys said it uses an API, which then might put it in the blockchain. You can hack it before it gets to the blockchain. I made a blockchain voting system myself years ago, and I discovered what anybody could have told you, which is that the blockchain is pretty much useless because that's not the problem where the security part is. All the blockchain does is record the votes, but all the security problems happen before you have data to put in the blockchain probably, so it doesn't really solve the main problems at voting. anyway, this time they have a better answer. Their official answer for this is now, they say, we are actually, version you tested was 20 versions old. You had to reverse engineer it and guess about stuff, but all you had to do was join like HackerOne, and we have a bug bounty program, and we would have given you the source code, and people are really testing it. So it sounds like in the last couple of years, they've moved from having no clue about security to sort of catching on to like modern ways to do this, because that's a pretty intelligent answer, saying we really are on a bug bounty program, we really give the source code to testers. It sounds like they're trying to improve their product, but I think the standard belief among security professionals is that no app and nothing on the web is remotely secure enough for voting, and I think that's true. But anyway, what they're doing now is using it for small numbers of voters, like ones that are out of town and stuff, and that's considered relatively harmless, because you know, you always use some secondary measure for those people, like mail-in ballots. There's nothing particularly secure about mail-in ballots either. Anyway, this is good, clean fun, and there should be a tweet about it too. I think this might, oh, we're already up to 10 minutes. I'll skip this stuff because we should get down to the official stuff here. All right, so we're here. This is 128. And so what I want to do is the usual stuff here, and then I'm going to have a secret part later where I talk about newly discovered vulnerabilities, because Louise was the first one to do this, and several students have been doing this. You can find API keys in the app the same way we've been finding passwords, and it turns out there's a lot of goodies in there. However, I've learned a lot more about API security to evaluate how bad these vulnerabilities are, but I'm pretty sure I found a few red letter ones already. But anyway, so the next thing I'm doing writing for 129S is API homework, where we're going to practice using APIs and learn exactly what you can do with these secrets, and then we'll be more qualified to determine exactly how dangerous it is to leak these secrets all over the place. Anyway, so we're here attacking Android apps. So we did the first bit last time, and now we're going to do attacking application components, and there's more coming next time. So Android apps can talk to other parts of the same app. The same thing's true of Windows, by the way. I remember when Windows Vista came out, and every version of Windows after that, if you just do netstat -an pipe more, you will find that it is listening on 127.0.0.1 on a dozen high-numbered ports, up in around 60 or 50,000. A bunch of internal Windows services are listening on the loopback address to other Windows services. I don't know why they do that, but it's doing a lot of talking to itself through the network port. And anyway, Android phones do the same thing. It's doing a lot of talking to other things on the same device. These things are called remote procedure calls. They've been around for a long time, and they're a huge source of vulnerabilities in Windows and Linux and everything. So anyway, you've got, in principle, any part of the app can send an intent to another part of the app, which is a request for service to another part of the app, which, if it is providing some kind of service, can then do it. So you can break things up. So we looked at Civ last time. Civ is this password storage app. And if you open this thing up, you can just use the mouse and click on settings up there, and you can get to the settings page without going through the login page first, which is a poorly designed app. And of course, the point of this app is to fail a lot of tests. So if you use Drozer, you can go and see the exported activities, which we talked about before. And you'll see these are activities that can be started from any app. And exported, now normally an activity is a visible page of the app, and it's normally only available to the app itself. But if you export an activity, then some other app can launch it. And this is what you might do if you are, for example, Skype, and you want somebody to be able to put a link on their web page that says, Skype me, and it'll send a message from that over to Skype and launch Skype. So you want to receive messages from other apps, and that might be fine. But you probably don't want the password list page of this app, which you should have logged in before you can see, to be exported so everyone can jump right to that page, and that's the problem here. So the unexported activities are here. You can see them with another command -u at the end of this Drozer command. And then you'll see activities that are internal to the app. And of course, they're safer. They can only be used by app. Of course, if you are root, you can launch them from anywhere, because that's the point of being root. Root violates the sandbox in Android. Remember, every app runs as its own user account, and all the security relies on other user accounts not getting in, but root can go anywhere. That's why rooting your phone is a serious security vulnerability. And some apps will actually detect that you're on a rooted phone and not run, not install. It would make a lot of sense if banking apps and everything would do that. By the way, I wonder if I remembered to start the recording. I did. Good. All right. Haven't forgotten yet, but I'm always a little nervous about it. It ought to have like a red button or something, but anyway. All right. So, All right, so Civ can't be launched from Drover because you can't run the start activity, but if you're root, you can do it. And remember, I mentioned before, Drozer is actually not necessary. Drozer is this app on the phone. You can do everything from a command line with AM, Activity Manager. You can launch everything. All Drozer is a simple shell to run some of those commands for you. Anyway, so Civ has a settings option, and you can get in there without logging in first, and you can also launch it here as root. So I can open the settings activity, and it'll look like that and put me in here, where I have options like change PIN and delete passwords, which I really shouldn't have gotten without logging in first. So you can have these insecure content providers, which you talked about. In earlier versions of Android, every content provider, which is a database, in most cases, SQLite, was automatically exported to everybody because for some reason they thought every database was public data, unless explicitly marked private. Now they're private by default, but anyway, you can see them here. And so you can see no permissions is required for any of these providers, except this one has /keys, has permissions. You must have the ability to civ read keys and civ write keys. Now that's what you should do. If you have some data, you should define some permission, and only after that permission should get in, but it only applies to /keys. That's the only path that is required, and those are not the only content providers. If you use another command to see the content providers, there's a /keys/ and a passwords and a password /. So those are content providers which have not required you to have a certain permission to get in. And therefore, that's the typical mistake. These are very simple mistakes. This is just like when you put a share on a Windows server and you make it full control by everybody. You just forgot to limit anything. It's extremely common. The technical term from OWASP of this is insecure direct object access. There is something on the device that should be protected. You have to log in first, and they forgot to make sure you log in before you go there. So it's just sitting there if you know how to poke it. So you can run a query, and you can do it from Drozer, so you're not running as administrator, and then you can get the hashed password here, which we did before. It's base 64 encoded and hashed, but you get some information, and we did this before. One thing you could do, by the way, is duplicate the password. You can make a new user with the same password, even though you can't crack it, for whatever good that is, and you can do a content query. You can find unexported content providers as well. We did this last time, and I'm going to see what this chat message is. Is this content a reasonable place to put API keys? Content providers. Well, that is a very good question, and I don't know the answer. Like I say, I've been finding these API keys, and I'm not finding any clarity in how secret they are. Even the ones labeled secret, some people say, oh, just throw them around, they don't matter. Other people say you have to keep them secret and put them somewhere like the secure storage place. There is a place called Keychain on iOS, and there's an Android secure place you can put secrets if you want to. And I wish I knew the answer. That's why I have not notified anybody of these vulnerabilities I'm going to show later, because I don't know how bad it is. And I'm not even bothering. I know nobody will listen to me anyway, and I'm certainly not going to bother talking to them until I have a chapter and verse. I want to be able to cite an authoritative document, like a NIST standard or an OWASP page that says, you are doing exactly what you shouldn't do. And therefore, I really need to know exactly what those keys do in the APIs I'm finding. Because I've definitely found tutorials to say, oh, just throw them in the app. It doesn't matter. This secret doesn't matter. Because I think the point is you can define an API key, and then you can limit on the server what that API key can do. So it can really only do one thing. So it really doesn't matter that people have the key, because you've limited permissions at the other end. I know this is true of Amazon Web Services keys. I've been to Amazon security talks, and they've talked about how you can put Amazon keys in places where people will steal them, but you should limit them on the server. And a common mistake, just like the one we're talking about here, is that people give full control to everything to their Amazon key and then put it in an app or something. And so there's no way to tell if they've done that without actually using the key and trying to do something. And I'm not in a hurry to do that without permission. So when I go through an app and I find keys, I'm not entirely sure how much I should be telling people about that. But if I find popular services like Facebook and Twitter keys, I should be able to find out what those keys do. That's my hope. Anyway, it's this is why I think this has not been that commonly done. So I was excited to do it, but now I'm finding it to be a little more work than I thought. But it is encouraging me to do what I should have done anyway, which is improve my web hacking class to where we really get into APIs. That was my goal this semester. We really have to do API hacking and API analysis more, because it's important. And I haven't found any books or anything to teach it to you, but I'm going to try and add some of it to that class so we become more educated about how APIs work in practice. Anyway, then there's SQL injection. We looked at this last time. You got SQLite. So you have a URL is the path of what you're going to, and you got parameters. And so this is select star from system. Looks like this. They call it a projection. So you can do this thing. And here you can put a apostrophe in there, and then you get a syntax error, which is unrecognized token. It's what the equivalent of a syntax error. And you can do SQL injection and pump out data. So that's the one, that's the equivalent of the old apostrophe or 1 = 1 dash dash in MySQL is this mess, which will now dump out information from the server. And projection star from SQLite master. This tells you the names of tables. So one table is called key and one table is called passwords and another one's called Android metadata. So that finds the names of the tables. This dumps the keys that with fields in the key table. And so the fields are ID and password, and there's metadata again. And now that we know it's ID and password, we can do this one, get the find the tables now, and then we can dump out the data, which we did last time. Anyway, by the way, there's something in your textbook which sounds really great, that you could actually run Droser to export the content providers as a web page. And then you can run web page vuln scanners on them, which sounded great, but I found it only worked in really old Android versions. But this is what it does. It listens on port 8080 on your device and now gives you every app on your phone. You can just click here and access it through a web interface. So then you can go directly to it. It looks pretty good, but it didn't seem to work very well. And then you can use things like SQL Map and other web vulnerability scanners. It gives you a web interface into all these methods, which sounds great, but it didn't seem to work in modern versions. Then there's a few other vulnerabilities to talk about. Samsung had content provider vulnerabilities leaking everything out. This was a pretty common thing. It's getting to be almost 10 years ago, but they had an open content provider leaking out this data, sort of like the homework project you did where that File Explorer, ES File Explorer, just publishes all your files openly on a mobile network port to the whole world. And it did that for years before anybody noticed. And all they would have had to do to notice is netstat -an and notice, why is my phone listening on some weird high numbered port? What happens if you connect to it? Oh, everything is just right there with no password, but this happens a lot. Anyway, so these guys didn't have any read permission and they had a SQL injection. All right, so content providers have other typical vulnerabilities. For example, content providers often, like PHP files in the web, they refer to a URL. And the URL can be adjusted through local file disclosure. This is local file inclusion. So you can redirect a URL to point to a local file. And so here's one that will read content from Civ. And Civ had a file backup provider, which could refer to a file name. So you could just put in system.yets host, and then you see the host file. So in principle, you see any local file. All right, and you can use it to see the master password. If you go into database db-wall, I've seen this in all the apps I'm studying. db-wall, I think, is the transaction table created while you're changing things. And in here, you'll see the commands that created the table and put the data in there. So among other things else, you'll see your password in plain text in here going into the table. So I've seen this in a lot of apps. And you've also got your email address down here and another one there. In fact, looks to me like I've got my usernames from the accounts I saved. I saved a Gmail and a Facebook account here, and I've got the emails there, and I think I might even have, that might have been my password, Twitter user. I don't know if those are just the emails or the passwords that leaked right out, but it had commands to put them in the database, and they were stuck in this cache that's available by directory traversal. So you can detect these things. There's a scanner in Droser that will help find these. Like all vuln scanners, you have to take its output with a grain of salt. Vuln scanners are all pretty weak. Anyway, so here you've got the /keys path, which requires certain permissions. And if you look in the manifest, it tells you those permissions apply, but they only apply to /keys. And this is a common vulnerability. So if you use /keys/, then you access the same resource, but it doesn't match the pattern in the manifest, and so the permissions no longer apply. So it's published to the whole world, and now you can just dump out the password and the PIN in plain text because it's stored in that table called keys. So this is fairly common. I see this a lot in Apache. In Apache configuration files, it's very easy to make the same mistake. Like referring to PHP files, you have a pattern, and there's a way to make a PHP file which will not be recognized by the pattern, and it will still be recognized by the PHP executor. So this is a fairly common vulnerability. You're able to upload a file which will run as PHP, but you don't need permissions to upload it, which you should have needed because the permissions had a different pattern matching flaw. That's a fairly common thing. All right, and then there's insecure services. Services on your Android phone are just like services on Windows or Linux. They're things that launch and are running all the time in the background, waiting for you to do things and providing services to other apps. So an app can bind to a service, or you can launch it with an intent. This is the same on Windows. They don't call them intents, but if you go into services in Windows, you can look at the start properties of your service, and a bunch of them start only when needed. So whenever somebody requests them, they will launch the service. So there's a method here which will receive intents, and you can interact with services that have started. So one of the vulnerabilities that came out was a privilege escalation, because the clipboard could copy files from one location to another. So you could have no permissions, and everybody could still get to the clipboard, and the clipboard could write to places that you didn't have a reason to get to. This is how you typically escalate privileges. You gain access to some other process which now has the ability to do something with higher privileges. That's how almost all privilege escalations work. You find a file with a setuid bit, or you find a service running. The simplest one I know is Windows XP Home Edition. Windows XP Home Edition, you could log in as a limited user account. If you open a command prompt and say at 6:30 CMD, at that time, the equivalent of cron, Microsoft's scheduled tasks, would launch it, and scheduled tasks ran as system. So when it launched the new command prompt, it was at system. You could just totally escalate that way. It's very common. This is how you do it. This is how you setuid files. All right. So unexported services, of course, you can launch them anyway with start and stop service, because you don't need permissions to do that. So that's not that surprising. Then there are bound services. If you want to allow remote procedure calls, so you want to listen to signals from other apps, then you can. There are various ways to do it. One way is to bind it, and then you have an iBinder object, which is sort of a handle to it. I understand it. Now you can extend the class. If you do object-oriented programming, you can have a class, and you can define another version of the class with different input variables, and it will have the same name but be treated differently. And you can do that, but that will only apply to other methods inside the same app. There's also something called messages you can send to each other, which I think is the most popular technique. And then there's something called Android Interface Description Language you can use, more complicated than messengers. These are various ways to listen to signals from other apps on the phone. All right, so if you want to attack these things, look for the handle message method, and that will show what messages are expected and how functions are executed. So Civ has a couple of these. You can look here and see it has a thing called auth service and a thing called crypto service, which have no permissions, so everybody can get to them. All right. So the auth, then you can look at the source code. And remember, we've done this before. For Android apps, you just have to take the APK and then take it apart and put it in JADX, GUI, which you've used a bit. Then you can see decompiled Java source code. And so you'll see the variables here. So there's a message check with 2354 and a type key and a type pin. So those are numbers just sitting there. And this is just what I'm saying about the API keys. There's constants just sitting there that give you the ability to do something. And in this case, they give us the ability to request information that we shouldn't be allowed to request. So we can request the password from another app. And so I can run app service send. This will send something from the Drozer client into Civ auth service, and now it will send a message with these numbers, 2354, 9234, and the pin 1234. So since I have the pin, I can now dump out passwords. And down here it is. This is the main password to launch the app. Remember this password, 1, 2, 3, 4, 5, 6, 7, 8. It made you have a 16-character password to launch Civ. So now here you needed to know a pin, but there's no rate limiting or anything on this, so you could just try all possible pins until you get in. All right. The broadcast receivers, these are things that are listening for signals from other apps, and you can send a broadcast. Now, these are internal signals, and sometimes people will send foolish data in those broadcast signals. And a broadcast signal goes to every app on the phone. So this is like listening to a network card and looking for broadcast traffic like ARPs. You can just listen to broadcast intents. So any app could send an intent. This is an unprotected receiver, a login receiver. and it's not filtered in any way, so it's listening. And any app could send this intent with run app broadcast send. And when you do, it will send that to every app on the phone, and so you can just sniff them. Those are called intent sniffing. You can just sniff them the way you sniff network traffic. So if an app sends an intent with secrets in it, which it can totally send a username and passwords and pins in an intent, if you write it sloppily and expect that, then anybody can sniff it. And all you have to do is run app.broadcast.sniff. This will just listen for broadcast intents, and you'll see them. Here it is with the pin and so on. And I think this is just like almost all these mobile device vulnerabilities. Fundamentally, it's hard for the end user to see what's happening on the phone. So you can have something like that ridiculous ES File Explorer that is just exposing everything for years and nobody will notice, because I guess for years, nobody ever logged in and got a shell and used Netstat to see what listening ports were. So you can just spray broadcast secrets all through the phone and nobody will notice, because unless they actually get root on their phone in the command shell and look, they'll never know what's happening. So it's, in general, this is the fundamental rule in security. If you can't audit something, it's not being done right. For example, there was a time when people had USB sticks. They scattered them everywhere. There was a survey about 10 years ago. They interviewed top executives. They said the average American executive owns 20 USB sticks and has lost 15 of them. And they were all full of company data and passwords and stuff. And so they became a big push about 10 years ago to encrypt those USB sticks. So everybody started selling encrypted USB sticks, and they became very popular, and people would pay like 30 bucks for one instead of 10 bucks. And then several years later, someone audited them, and most of them were not encrypted. Why should they be? You just put it on the box. But now what they did was, at that time, when you plug a USB stick in a Windows XP machine, it would launch an app that it found on the USB stick automatically. And what they did was they made an app that would ask you for the password on a Windows machine. And then it wouldn't let you see what's in the app file until you entered that password, but nothing was actually encrypted. It's just like a toll booth in the desert. So all you had to do is put it on Linux or run a forensic tool or anything. It was not really encrypting anything on there. And that's why if you don't audit security, it's usually something awful. Of course, another thing to say is this was protected to some extent. You couldn't just pick up those USB sticks, plug them in your laptop, and get the data right off them. There was a barrier of some sort. It was just not as strong a barrier as you probably want it to be, but they would say, now your data is password protected. And you could say that. There's some truth in that. And by the way, this is all any security barrier ever is. It looks strong to you, and so somebody understands how to get through it. It's nothing. Like you can have a safe, and there are some students around here that can just totally crack into a safe. Other people think, well, I'll put it in a safe, nobody can get in there. But there's some people that can get through that. So every barrier you have is always like this. You're only going to stop a certain level of attackers. Other attackers will sail right through it. Anyway, so yeah. You should totally give a talk at like B-Sides or something. I want to hear how you hacked in a safe. Anyway, all right. So there's secret codes, by the way. This is something that got a lot of press, good, clean fun. You can dial these special codes. There's star 69. Everybody knows that one to see who's calling you. And then there's a bunch of other ones that do special things, and you can use the scanner to find the secret codes available on your phone. So here's one way to find them. So *#* 4636 is one of them, and you see it there, Android secret code. So there were a bunch of these. If you dial that on your Android emulator, it will then open this testing page, which is not too exciting, but it does open a special page if you dial that phone number. And there've been a lot of others, like Samsung Galaxy had one that would remotely wipe your phone. And they had a vulnerability so you could automatically make a phone call from a web page link. And you could make it so it automatically happens by putting in an iframe or something, so you don't even have to click the link. You just visit the page, it dials this number and wipes your phone. Ha, ha, ha. So you could also have a page that would automatically make Skype calls and stuff at this time, because this is how you find out. I set one up here that'll do a couple of them, and it'll take you to that settings page. It's not too exciting, but anyway. So those things got a lot of press. I think they're not as common as they used to be. But anyway, I got a few cahoots to show you, and then I want to get into the confidential stuff. So this is 128.7b. There it is. Oops, that's the wrong one. Back, I say, revealing my top secret information. All right, so at least I don't have any very good top secret information. Considering how sloppy I am, it's a good idea I don't have a security clearance. So I'm really not as careful as I would have to be. Anyway. What's that?
Have you lost 15 USB sticks?
Oh, I'm sure I have. Oh, actually, I've got a bag at home with like 60 USB sticks that I took to China and passed around at DEF CON China. And then I intended to take them back here and use them at B-Sides and DEF CON and everything, but I lost them. And then Liz told me, those are all full of god-awful malware. I said, well, they probably are now that you mention it. And I said, you know, I could have been like the coronavirus guy bringing back this horrible stuff. And I still found them. I found them yesterday. I got this bag of USB sticks. Given to my students who want to do malware analysis or something. They tell me there's all sorts of exotic, horrible stuff on there because I just passed them around 80 students in China. And of course, they all plugged it in and everything. I'll probably do it again if they have DEF CON China again. They canceled it this time because of the new virus, but I got to bring a ton of USB sticks. They can't get to Google or anything. I got to bring a bunch of stuff, but I really should be wiping them after the con, which I didn't think of, but instead I lost them. So it amounted to the same thing.
Spanish food, a lot of people that started in Kansas.
Oh, really? It did originally start in Kansas? Yeah, I know. That's why they said the official rules are you got to quit naming it after animals or places because then everybody will blame them, and it's often not true. Yeah. So that's why they had to give it a neutral name like COVID-17 or something. Anyway, this is CNIT 128 Cahoots, and it is 219. All right, so I'm ready to record the winners. My goodness, unless this is a fake person, that's suspicious. Using the right name, that's like trying to throw me off. Maybe so. All right, I guess people are in. Let's do it. So if you fail at the first stage in a multi-stage login, is this the right one? I have a suspicion it's the wrong Kahoot. That does seem like 129. Let me see if I can figure out what stupidity thing I did here. That is 129. Let's try finding the right class. Otherwise it isn't. 128. There it is. Now I feel better. All right. This might be related to Android or something. Boy, I don't know.
How will I ever figure out if I was right?
What's that?
How will I ever know whether I was right or not?
Oh, that's right. Yeah. Yep. You'll never know. Take 129 tomorrow. But anyway, yeah. This might be better. Right, so theoretically, this will be the right Kahoots. Boy, I don't know. It's a good thing these classes are free. I remember when they first hired me, the woman interview, she said, what would you do if a student said, you don't seem to know very much? And I would say, well, you didn't pay very much to take this course. And she said, well, we try not to say that. And I said, why not? Isn't that exactly what's happening here? I mean, we're the discount education alternative. She didn't like my attitude, but I thought I had the right attitude. So that's why I boldly, ever since we had Free City College, I always tell people, my classes are worth more than you pay for them. So, and nobody goes in debt to go to take these classes. You don't go out over 100 grand in debt or anything. This is socialism.
College like 90% subsidized by the state of California.
Yeah, it totally is. Yeah, so I mean, it was never very expensive, but now it's even less. So, all right. I think I might have enough people. She's grown more faces here. Are those angry birds? That's bugs or ants or something. I don't know what those things are. All right, anyway, all right, so this might be the right class. There we are. Privilege escalation on Samsung. All right, it was an exported service. Anyway, all right. Which component has to be protected to prevent intent sniffing? You limit your broadcast receiver instead of just spreading the data everywhere. All right. All right. Which one makes a screen pop up and can be launched from browser? Okay, that's exported activities. Droser runs not as root, just as another app. So only exported activities can be launched from there. If you are root, you could also launch unexported activities. All right. And which one might have SQL injection? We've got a little bit of CISSP thinking. Of course, every content provider might in principle have SQL injection, but the significant vulnerability comes when they're exported, and some other app could do it. Anyway, so the glorious winners, Peter Chia, real name. Someone might actually get points. Now here's where I'm having a problem. Right. I assume not Caitlin is really Caitlin. I think I'm going to go with that. Okay. And the pig. Pig will have to come out of the closet if they want to have their points. You're looking at me funny. Are you the pig? Okay. Aha, a chat message might be identifying the pig. Might be Ed. Okay, are there in Android binary obfuscation? Yes, there are. Oh, not source code obfuscation. Well, let me just save this and close this so it stops playing silly music. Well, see, Android, okay, Android isn't really a binary. Android is in Smalley. It never gets down to any lower level. So you obfuscate the source code in Smalley, and there you use tools like -O and ARXAN, ARXAN. Those are commercial tools that thoroughly obfuscate. They change all the variables to like 20 random characters. So that slows down people, although you can still get in, but it does slow you down. You can't no longer look for things like passwords and stuff. Now on iOS, you can strip symbols the same way you do in compiled code on Windows. And so it doesn't have as big a problem, but I'm not aware of any way to further obfuscate it. Any strings you put in are still readable. And as far as I know, it's just your obligation not to store secrets in strings. But there may be some way to do this. I am not aware of a tool that does that though. But I suppose there might be. It would probably also apply to normal code on Linux and Windows. C code, if you have strings in C and you want to obfuscate them, there may be some kind of library that will automatically scramble them and unscramble them. I guess it would be easy enough to write your own string processing routines or to, but I'm not aware. I don't know. It's a good question, and I don't know what it would be in C. I know for Android, it's ARXAN and -O are two of them, and there's a lot of them. Although as far as I can tell, nobody uses them. None of the apps I ever study have ever bothered to do anything except ProGuard, which does nothing. But those tools are selling to somebody, just not banks or anybody serious. I think game developers use them. Anyway, the C-based tools, I don't know what they are. If anybody does have a good idea, let me know. Any C developers out there? Yeah.
Basic question. What is that -U switch you keep on using?
A -U is for unexported things. In Droser, yeah. All right, good. Well, all right, any other questions? I'm going to stop the share then, and then I will talk about the confidential stuff. All right, let's stop the share and end the record, end the meeting. All right.